So this is CPM Precalculus Chapter 2, Number 6. Here we're asked to sketch or use your calculator to make a graph of the piecewise function g of x. So g of x is defined to be 2 to the x for x less than or equal to 2, and negative 2x plus 9 for x is greater than 2. Okay, so I see right away that the two pieces change, right? We change from one piece to the other when x is 2, right? So let me just go ahead. I want to note that because I don't always need to draw the whole thing and then erase. Sometimes I can just go ahead and draw up to the point. Okay, so here is x is equal to 2, right? Here's my x-axis, my y-axis. And so less than or equal to 2 is to the left of 2, right? I know that way. And I want to sketch the graph 2 to the x. Well, this is a parent function, so I know this one already. Let me go ahead and put some more points. I'm going to make these all one unit. So this is negative 1, negative 2, negative 3. Okay? So if I graph 2 to the x, let me use green. I know if you plug in 0, 2 to the 0 is always 1, right? So at x is 0, our output is 1. At negative 1, I know that's going to be 2 to the negative 1 power, and I know 2 to the negative 1 is just 1 over 2 to the positive 1, or 1/2, right? So I know that at negative 1 it's just 1/2. And in fact, I know that this keeps to the left, it keeps getting smaller and smaller and smaller, closer to our x-axis, but never crossing it, never touching it, okay? So if yours should never touch it. It gets closer forever, but it never touches it, okay? So let me just go ahead and draw that, okay? And to the right, at x is 1, 2 to the 1 is just 2, right? X is 2, 2 times 2 is 4, 1, 2, 3, 4. So it looks like this, right? A little smoother than that. So it's going to be like this. Okay? Anyway, so that's the graph of g of x for x is less than or equal to 2. So I know this is a closed circle here because less than or equal to 2 includes at 2, right? Includes the point 2. Okay, and to the right, I know that it is going to look like, let me use a different color. It's going to be negative 2x. Oh, that's not a good color choice. Let me choose orange. Negative 2x plus 9 for x is greater than 2. So that means to the right of 2, not including 2, this is my graph. Okay, so at x is equal to 2, if I were to plug that in, 2 times negative 2 is negative 4. Negative 4 plus 9 is 5. So it would be up here at 1, 2, 3, 4, 5. But I'm going to draw it as an open circle, right? At x is equal to 2. Y here is equal to negative 2 times 2 plus 9, which is 5. But I know it's an open circle because it's just greater than. Okay, so how about at 3? At x is equal to 3, I get y is equal to negative 2 times 3, which is negative 6. So negative 6 plus 9 is 3. So here at 3, it's going to be 3 here. All right, and actually I can look at the line and know it's just going to be going down 2 over 1 because the slope is negative 2. So down 2 over 1, down 2 over 1, down 2 over 1. So it's just going to basically be a line connecting these points. Okay? And again, I want to put them both in the same color because these are all together g of x. Right? We don't have a green and an orange graph. We have one graph, g of x. Okay? So this is what it looks like. Over here on the left, it's kind of a curve going down, down, down closer to x, the x-axis. On the right side, it's just a straight line going down and the right. Oh, right. So let's say I wanted to use my calculator to verify or to help me. Either way, I want to sketch this on my paper. So I could put, remember in parentheses, I would put 2 to the x, right? Because that's the first part. And then to make it 4x is less than or equal to 2, I open up a parentheses and I put x is less than equal to 2. So to get less than or equal to, I do shift math to get to the test, go down to number 6 is less than or equal to, and then say less than or equal to 2. Add, remember I add these together, and I put negative 2x plus 9 is the second one, right? And I want to say for x is greater than 2, so I say x greater than 2. I do second math to get to the test again. Number 3, 2. Okay, so this is how I enter g of x into my calculator. I graph it. Okay. All right. So that kind of looks like this. Now let me change the window to look more like this window here. Because remember, I went from negative 1, 2, 3, 4, 5, 6. So this is x is negative 6. So 1, 2, 3, 4, 5, 6, 7. X is positive 7. So x minimum, I'm going to say is negative 6. X maximum is 7. Each one is by 1. Okay. My y minimum, I'm going to say is negative 3. Right? Negative 3, negative 2, negative 1, 0. 1, 2, 3, 4, 5. Let's go all the way up to 6, just so we get above that point. So I'm going to go from negative 3 to 6, okay, and graph it again. All right. So this looks similar. Again, our graphing calculator has problems when it has an open space. Right here we see an open space or a gap, right? We have there's not a connection between the point here and here. And if you zoom in, and I want to make the cursor zoom into that region where there is that gap or open space, or should be, and we're just going to see that the calculator just puts that line to connect them, okay? So that is something we know technology does, but we do not want to see, so do not include it in your sketch, and you have to realize that and check for these things if you use your calculator, okay? So that was sketching or using your calculator to graph g of x. So part A of the question then, all right, we didn't even start part A. Part A is just saying find the domain and find the range. Okay, so this is really good practice. If you know it, please go ahead and do that. Remember, the domain, we're looking for all the x values that give us a y value. So again, here, do we have an x value here? Yes, because of that arrow. So we're starting at x values all the way to the left, right? From our graph, we have the x values all the way to here. So from negative infinity, at 2, it stops here, but starts again here. So it continues on, and we get x values all the way to positive infinity. Okay, so that is our domain. Our range, okay, well, we look at the y-axis, and starting at negative infinity, we know this section here goes all the way down, right? So that means our range is starting at negative infinity, and it goes up all the way to here, right? And then it stops at this line right here, right? At y is equal to 5, okay? And since it's an open circle at this point, we exclude it using our parentheses, okay? So that is part A. The domain is for x values negative infinity to infinity, all x values. The range is negative infinity to positive 5, so it's basically y values from negative infinity all the way up to 5, right? And then finally, part B asks, is this equation continuous for all values in the domain? So continuous. Okay, so remember, continuous means I can take my pencil and keep drawing without lifting it. And I had to lift it to get to this section, right? Because there's two sections that have a little open space. So is it continuous? No. I have to lift my pencil. And where do I have to lift my pencil? I have to lift my pencil right here, right? Where x is 2. I have to lift my pencil at x is equal to 2. So if I started at the right, I could go all the way to x is 2, draw the open circle, but I would have to lift it to get to this section. Okay? So no, it's not, because I have to lift my pencil at x is equal to 2 to draw the graph. To draw the graph of g of x. Alright, so this ends CPM Precalculus Chapter 2, Number 6.